Hi all and welcome to today's class. So it is the 30th of April and this is class number 84. So we're taking a little bit of a break from our adding and subtracting fractions. We're still sticking with fractions, but we're going to look at fractions in an equation. Now, we've actually already touched on this. We did this at the start of the year when we were revising algebra the first time. We went through it in a lot of detail and we talked about how we can work with fractions. We did it in one class, so I'm sure there's a lot of you who are thinking, I don't remember that. But we will revise it again today and we'll look at a lot more complicated examples because now we've worked with a lot more complicated algebra fractions. So this is the last piece we have to do on fractions. That's the good news. After this, we're moving into distance, speed and time, which will give you a bit of a break from the algebra. So just get through this one more day. So I'm going to correct the homework that you had last night, first of all. You had some more complex and the hardest of all the algebra fractions to add and subtract because our algebra is now in the denominator. So we had 2 days of working with the algebra just in the numerator. Now it's in the denominator. This first equation was lovely and easy because the denominator is already common. So we have a -2 and a +3, and that ends up giving us a 1 over x minus 1, and that's our final answer. So then we got into these questions where the denominators are not the same. Now, if I want to get the lowest common denominator of 4x minus 2 and 2x minus 1, I simply multiply them together. Now at this point here, we're not going to multiply them out. We're going to leave them as is. I'm going to rewrite my fraction just to give me a bit more space. Watch that sign. I'm seeing a lot of signs going wrong in homework. Really pay attention to those signs. I have the 4x minus 2 already here, so I'm going to multiply that by 2x minus 1. If I multiply the bottom, I have to multiply the top. I have a 2x minus 1 here, so I'm missing, put this in a bracket, a 4x minus 2. If I multiply that by the bottom, I have to multiply it by the top. Then I combine. My lowest common denominator is 4x minus 2 times 2x minus 1. On the top, I have 2 times 2x minus 1. Then I have minus 1 times 4x minus 2. I'm now going to simplify my numerator. So I have 4x minus 2 minus 4x plus 2. Watch your signs. Some signs going a bit funny for people as well. That gives me 4x minus 2 on the bottom and 2x minus by 2x minus 1. So now cleaning up that top line, 4x minus 4x, they cancel out. Minus 2 plus 2, and actually we get 0 divided by 4x minus 2 times 2x minus 1. Now, 0 divided by anything is simply 0. So if you multiplied out that denominator, you did extra work, and that's absolutely brilliant. I will multiply out that denominator just in case anyone did and wants to check their work, but this was not required. So we have 8x squared minus 4x plus 2. That's 8x squared minus 8x plus 2. So that is what the denominator would have expanded to if you did, but there was no need. Final answer is 0. Part C. So our lowest common denominator of x minus 2 and 2x minus 1 is simply the two denominators multiplied together. And I'm going to rewrite my fraction to give myself a bit more space. X minus 2 plus 1 over 2x minus 1. And the denominator, I have the x minus 2, so I'm going to multiply that by 2x minus 1. Here I'm going to multiply by 2x minus 1. I have a 2x minus 1 here, so I'm going to multiply that by x minus 2. And the top line by x minus 2. Now I'm going to combine, and my lowest common denominator is x minus 2 times 2x minus 1. The top line is 3 times 2x minus 1 plus 1 times x minus 2. I'm now going to clean up my numerator. So I have 6x minus 3 plus x minus 2 all over x minus 2 to x minus 1. Now, tidying that up even further, I get 7x minus 5 all over x minus 2 to x minus 1. Now, I'm going to take that bottom line and I'm going to expand it. So I'm going to have x times 2x minus 1 minus 2 times 2x minus 1. That gives me 2x squared minus x minus 4x plus 2. That is 2x squared minus 5x plus 2. So my final answer up here becomes 7x minus 5 all over 2x squared minus 5x plus 2. So there's a lot of work in each of those questions. So then we move on to question 2. So something interesting happens in question 2. So let's see what happens. So lowest common denominator of x plus 1 and x minus 1 is x plus 1 by x minus 1. So rewriting my fractions just to give myself a bit more space. I have 3 over x plus 1. Oh, nearly put in a plus. It's a minus, what's your signs? 2 over x minus 1. The denominator has an x plus 1, so I'm going to multiply by an x minus 1, and the top line by an x minus 1. Here it has an x minus 1, so I'm going to multiply by an x plus 1, and x plus 1 up here on the top. My lowest common denominator is then x plus 1 times x minus 1, and I get 3 times x minus 1 minus 2 times x plus 1. That gives me 3x minus 3 minus 2x minus 2 all over x plus 1 times x minus 1. Now, cleaning up that top line, I get x minus 5 all over x plus 1 times x minus 1. Now I'm going to take my bottom line and I'm going to expand it. So I have x plus 1 times x minus 1, which is x times x minus 1 plus 1 times x minus 1. That is x squared minus x plus x minus 1. And the x's cancel, leaving me with x squared minus 1. And that's quite interesting. Well, I think it's quite interesting. And if we were in the classroom, what I would be asking is, is there something that we could have spotted about those two brackets that would have maybe made it easier to get to x squared minus 1, or at least allowed us to know that we were right because we got to x squared minus 1? And actually, if you take a look, this step going backwards is difference of two squares. So remember, a difference of two squares are the brackets are the same, but have different signs. So then when we're going backwards, so this way, the multiplication way, we'll end up with an answer that looks like something that we would use a difference of two squares. So that would be two square numbers with a subtraction between them. It's kind of interesting. And as you get used to the algebra piece, that can be used as a shortcut to work backwards. So let's look at part B. Lowest common denominator of x minus 3 and 2x plus 1. That is simply x minus 3 times 2x plus 1. I'm going to rewrite my fraction. So x minus 3. I'm going to multiply that by 2x plus 1 and the top line by 2x plus 1. Plus 4 over 2x plus 1. So we're going to multiply that denominator by x minus 3 and also the numerator by x minus 3. So this means we have x minus 3 times 2x plus 1, and we get 3 times 2x plus 1 plus 4 times x minus 3. Multiplying out the numerator, we get 6x plus 3 plus 4x minus 12 all over x minus 3 times 2x plus 1. Cleaning that up, that gives us 10x minus 9 all over x minus 3 times 2x plus 1. Now let's expand that bottom line. So we'll take the bottom line and multiply it out. We get x times 2x plus 1 minus 3 times 2x plus 1. That gives us 2x squared plus x minus 6x minus 3. So 2x squared minus 5x minus 3. So our final answer is 10x minus 9 all over 2x squared minus 5x minus 3. And our last question. Notice that our denominators this time are two brackets that will look the same, but with different signs. So we're going to have the same thing we had in part A of this question, so 2 part A, and that is when we multiply them out, our answer is going to be a difference of 2 squares. So take a look now and see, could you then use a shortcut to have that multiplied out? Think about that. That little shortcut. Could you figure out that shortcut? Remember, with any of these shortcuts, I never mind you using them as long as you're using them right. So if you do want to use it, just message me just to double check that you have it right before you start using it. I'm happy for you to use it then. So here I have 3x minus 1, so I'm going to multiply by 3x plus 1, and the top line by 3x plus 1. Here we have 3x plus 1, so we're going to multiply by 3x minus 1. So multiply by 3x minus 1. So lowest common denominator here is 3x minus 1 times 3x plus 1. We have 2 times 3x plus 1 times 3x minus 1. That is 6x plus 2 plus 3x minus 1 all over 3x minus 1 times 3x plus 1. I now have 9x plus 1 all over 3x minus 1 times 3x plus 1. Now let's take that bottom line and let's expand it. We're going to have 3x times 3x plus 1 minus 1 times 3x plus 1. That is 9x squared plus 3x minus 3x minus 1. These cancel and I have a 9x squared minus 1. So I get 9x plus 1 and a 9x squared minus 1. Now don't do any funny cancelling. Remember, we cannot simplify unless we have factors. So none of those 9's cancel or the x's cancel or the 1's cancel. Don't do anything funny. This is our final answer. So before I move into the new work for today, I want to touch on something that has come up this week, and I didn't touch on my other videos, but I did say to anybody who had kind of done something with this that I would touch on it today. So this is going back to a question that I gave you on Monday, and you have 3x over 5 plus 2x over 3. So much nicer question. So lowest common denominator of 5 and 3 is 15. So I'm going to multiply this fraction above and below by 3 and this fraction above and below by 5. Much easier times. So now we combine them, so we get it over 15, and we have 3 times 3x plus 2x times 5. It doesn't matter what, that 2 looks a bit funny. It doesn't matter which order you put it in. Remember, multiplication is commutative. So what that means is it doesn't matter what order we do it in. So 10x, 15, and our final answer is 19x over 15. Now, this is where the question came in about, should we leave it as a top-heavy fraction or should we change it to a mixed fraction? So if it was just 19 over 15, so I'm going to do that over here. So if we weren't talking about algebra and it was just 19 over 15, a lot of you would change that to 1 and 4 over 15. Now, that's a mixed fraction, so it's mixed as in it has a whole number and it has a fraction piece. I am not a fan of mixed fractions. I tend to avoid mixed fractions unless specifically asked. The reasoning I have for that is because actually working with mixed fractions in your calculator is very, very dangerous, probably not the right word, but as in it's very difficult to put mixed fractions into the calculator correctly, because often what the calculator reads it as is 1 multiplied by 4 over 15. So try it now to get your calculator, see if you can like put that into your calculator and like, I don't know, multiply it by 1 and see do you get the right answer. See, can you play with it? There is a specific way to put in mixed fractions in most of the calculators. It's kind of obvious on the Casio. It's a little less obvious on the Sharp, but I'm just not a fan. Okay, so I would rarely do that unless I was specifically asked to. I like top-heavy fractions. As our algebra gets harder and as you go on and finish your junior cert and go into leaving cert, top-heavy fractions are always much easier to work with. Now, that being said, I will never tell you that it's wrong to have a mixed fraction. So if you want to do that, work away, no problem. However, when we talk about algebra, we don't have 19 over 15 and then just an x. We have 19x over 15. So where that x is, I suppose you could work it into a mixed fraction, but I wouldn't. And the reasoning behind this is because, remember, x stands for some number, and we don't know what that number is. And if that number was bigger than 1, then that number is definitely going to make a numerator, the top line, bigger than the bottom line. Because if you multiply 19 by 1, you get 19. If you multiply by anything bigger than 1, it's going to be bigger than 19, and so on. But if x is a small number, or a fraction, or a decimal, maybe you'll end up with a numerator that's actually smaller than the denominator. So maybe 19x is actually smaller than 15. Maybe. We don't know. So I would never change it into mixed fraction because we don't know what x is. So technically, do we know for sure that it is a top-heavy fraction? This is kind of down to good practice. And I talk about that a lot, but really good practice would be leave it as is. No need to change it into mixed. That being said, you do need to make sure it's in its simplest form, okay? So know the difference between changing it to a mixed fraction and making sure that there any common factors are taken out. So as in, if it can be divided above and below the line by a number, make sure that that is done. Okay, so let's jump into equations. So this is what we would have seen at the start of the year, and I would have talked about this in a lot of detail. So we have 3x over 4 is equal to 6, and it is an equation. It's quite a simple equation except for that fraction. So the question that I put to you is, like, how many quarters does it take to make a whole? How many fifths does it take to make a whole? How many sevenths does it take to make a whole? And we started to make this connection between the denominator and how many of them were needed to make something whole. So if I said to you I have 3 quarters, like how many 3 quarters can I have until I have a whole? And that sounds like quite a complicated question, but actually, if you take 4 of them, then you'll definitely make it whole. So the trick we learned, and the trick we're going to use today, is you multiply both sides, and I'll try to get my pen working. So multiply both sides by the denominator. And I'm going to go one step further here, and I'm going to say by the lowest common denominator. Now, good news is I've only one denominator in this question, so that is by default the lowest common denominator. So what we do is I'm going to keep my colors, try to keep my colors consistent. So I'm going to multiply this side by 4, and I'm going to multiply this side by 4. So remember, balance. Have I done the same thing on both sides? Yes, I have. And effectively what you're doing on this side here, and I'm going to do a little aside over here. So I'm doing 4 times 3x over 4. So that's like 4 over 1 by 3x over 4. And when we multiply fractions, we multiply across the top and across the bottom. But then you'll notice that 4 divides into the top and divides into the bottom. So we're left with simply 3x over 1, or 3x. So what is easier is for us at this point to cancel out those factors, because this line here could be written as 4 times 3x all over 1 times 4. Okay, because you're multiplying across the top, across the bottom. So what this looks like when we're actually doing the sum is we cancel this 4 with this 4. We get rid of it. The whole purpose of that multiplication was to get rid of the fraction. And we're left with 3x equals 6 times 4, 24. And then we finish it off, divide both sides by 3 as normal, and we get x equals 8. So we did touch on that before, and I did say I was coming back to it. Here I am coming back to it. And the rule is that you multiply both sides by, I'm going to change that now to not just the denominator, but the lowest common denominator, because we could have a question that has multiple fractions, like this one. So for example, here, first thing I'm going to do is get lowest common denominator. Getting into kind of a habit of, you see fractions, you get a lowest common denominator. So we have 3, we have 4, and we have 6. So the lowest common denominator is 12. So what we're going to do, we don't have to figure out anything like we do with adding and subtracting. We simply multiply both sides by 12. Now, next thing I will actually say is instead of both sides, because that was very simplistic for our example, we're going to multiply every term by the lowest common denominator. You'll effectively get the same thing, but it's much easier to work with because 3 divides into 12 4 times, 4 divides into 12 3 times, and 6 divides into 12 2 times. Now all my fractions are gone and I'm left with 4 times 2x minus 3 times x equals 2 times 5. So that is 8x minus 3x equals 10, 5x equals 10. Divide both sides by the coefficient of x to finish that off, and we get x equals 2. So actually, quite a complicated looking example that turned out to be quite easy. So why was I not doing this for the last 3 days? That's the question. Why have I suddenly now pulled this method out of my hat when I made you do really hard stuff for the last 3 days? And I would say to you, think back. What do we have today that we didn't have in the last 3 days? And the answer is we didn't have an equation. So we treat fractions differently depending on whether we have an expression, so just two fractions not equal to anything, or if we have an equation. And the reason we treat it different is because an equation is about the balance. And remember, as long as you keep the balance, we can do whatever we like to an equation. We can add a number to both sides. We can take away a number from both sides. When we have an equation, all we care about is keeping the sides equal, keeping that balance. So I can multiply across the equation by a number, no problem. If you look back on the work from yesterday, did we have an equals? Did we have an equation? And the answer was like, no, we had an expression. So you can't change an expression. You can change an equation. And it's a really important idea to know when can you do this and when do you have to use the other method for adding and subtracting fractions. So now let's look at a slightly more complicated example. We want to again look for our lowest common denominator of 4, 3, and 2, and that is 12. So we're going to multiply the first fraction by 12, the second fraction by 12, and the last fraction by 12. So as long as everything gets multiplied, we're keeping its balance, okay? I do a little bit of simplifying first, and then I have 3 times 3x minus 1 plus 4 times 2x, and that equals 6 times 5. And then I get 9x minus 3 plus 8x equals 6.5, 30. Here I have 17x minus 3 equals 30. Vertical balancing, if you're doing it, we're adding 3 to both sides, or you can simply say I am adding 3 to both sides, and that will give me 17x equals 33. And then we divide both sides here by 17, and we don't get a particularly nice answer. We get x equals 33 over 17. And that's okay, because sometimes we're gonna get answers and they're not particularly nice. I know if I was doing this in class, my question, well, what you would ask me is, can you leave it or do you have to change it to mixed fraction? Remember, I like top heavies. I will leave it as is, but you can change it. There's no problem at all. But don't panic when you see a fraction as an answer. So I want you to try some of these now. I've given 21 questions. I don't want anyone panicking now as you see them. What I would say is I want at least a minimum of 12 done, which should be doable because the first few are very, very quick. But the other ones are there if you want to keep going and to extend yourself. Okay, so minimum 12. And I'll write that up in your assignment so you can see it. But if you want to keep going, you have then the extra 9 to do so. Um, I would say I don't mind if you want to pick the harder ones to do as well to prove that you can do them. That's absolutely perfect. But 12 minimum out of this page to have for me for Monday. If you have any questions, let me know. I will be correcting all of these. So you'll be doing them for Monday. You'll be doing them on Monday, even if you don't get a chance to do them today, or over the weekend. And we'll finish that off and we will draw a line under algebra. We have one more piece of algebra to do, but we'll do that after we look at distance, speed and time.